Here is a question from your test in geometric and algebraic vectors. Now we will use the concept of scalar multiples here to solve the problem and see how easily it can be solved. It's a very tough problem, right? And I've seen it in test papers so many times. The question here is, in the trapezoid ABCD, if AB is 2/3 of DC, prove that AE is equal to 2/5 of AD plus 3/5 of AB, right? So that's the problem. So read it once again, try to understand the problem. Figure is given before you and try to attempt it. Now the strategy which we are going to follow here is of similar triangles. You remember that similar triangles have sides in a fixed ratio, correct? So ratio of sides is constant. So in a way they are scalar multiple. So that is how similar triangles and scalar multiples are related, right? So let's look into the statement. When I say AB, vector A to B, is 2/3 of DC, that basically means that the ratio of AB and DC is 2:3, right? That means if AB is, let us say, 2x, then DC is 3x, right? 3 times x, correct? So x is the vector we are saying in this direction, right? This is like, I'm trying to give you a concept, right? So if you look like this, if you see it like this, then you will see AB, let me write here. So we have AB over DC is equals to 2x over 3x, right? That is 2/3, right? Does it make sense? So it is AB over DC is 2/3, correct? You can also write what is DC equals to. We can write DC is equals to, from here, 3/2 AB. Correct? That means DC, the longer side, over the shorter side, is in the ratio of 3:2. Do you see that? X and X will cancel out, the vectors, right? They will cancel out and you get the ratio, the constant 3/2, right? So that is the concept. Now, what is a trapezoid? ABCD is a trapezoid. Trapezoid is a quadrilateral where the opposite sides are parallel, and that is why we are taking vector x in both the directions, right? And 2 times x is a scalar multiple, so that means x is probably like this much, right? So x and x, 2x. Here it will be like this. Do you see? X, 2x, 3x, scalar multiple. So that is how you connect these things together. Now, as you can see here, if you consider the triangle AEB and triangle DEC, they are similar, right? So we have triangle AEB is similar to triangle CED. Now, why are they similar? These two are parallel sides of the trapezoid, right? Now, since they are parallel sides, then if you see these angles, they are vertically opposite angles. They will be same. Now, these angles are alternate angles, correct? These are parallel sides, that's the transverse line, and these are alternate angles. So they are equal. And here also, these are alternate angles, correct? Between two parallel lines with a transverse line. So because of the property AA, right? So angle, they are similar triangles. Since they are similar triangles, ratio of their sides is constant, correct? So when we say AB over DC, we have AB, that means the smaller side from here to here is over DC is equals to 2 over 3, so that is a constant. Then AE over EC will also be 2 over 3, correct? Right? Because all the sides in a similar triangle are in the same ratio, 2 over 3. So let us say this direction, we give a vector y in this direction. Then this will be how much? Because they are in the ratio of 2 over 3, this will be 2y. And this much from E to C will be 3y. Do you see? Because they are in the same ratio. Correct? So I am developing the concept which will help us to solve the problem. Now, can you relate this AE with AC? So AC will be 2 plus 3, 5y. Do you see that? AC will be 5y. So what is AE over AC? AE over AC is 2y over 5y. So it is 2 over 5. Right? So all this I am trying to show you that these are similar triangles. Since they are similar triangles, ratio of their sides are 2:3. And if we consider small and big triangle, in that case, this is 2, this is 3. So if we add this up, it is 5, so it is 2 over 5. Do you understand the ratio of these sides? So AE over AC will be 2 over 5, right? So that is what we have understood from the similar triangles. Now, let's try to solve this problem. Now we have here AE equals to 2 over 5 of AC. Correct? So AE is 2 over 5 of AC. So AE, this is 2 units, and AC is 2 plus 3, 5 units, right? So 2 over 5 of AC. Now what is AC equals to? AC is AD plus DC, correct? So I can write this as 2 over 5 of AC is AD plus DC. Correct? Now, what do we need to prove? A is 2 over 5 of AD, but we want something in terms of AB, not DC. This is how you have to see while solving. Now we know DC is 3 over 2 of AB, as we wrote here. So we can rewrite DC. So we get this as 2 over 5 of AD plus DC can be written as 3 over 2 of AB. That is given to us. Right? 3 over 2 of DC, correct? So that is what we get. Now if we open the bracket, what do we get? We have proved AE equals to 2 over 5 of AD plus when you multiply 2 over 5, 2 will cancel, you get 3 over 5 of AB. Correct? So we get AE equals to 2 over 5 of AD and 3 over 5 of AB. This. So we related this back to AB and got a result. I hope you understand and appreciate this, right? So to solve this problem, what should we do? First step, trapezoid AB is parallel to DC, right? We should write here AB is parallel to DC, right? Why so? Since it is a trapezoid. Now since they are parallel, the triangle AEB, the small triangle here, is similar to this big triangle property AAA, angle, angle, angle. And their ratios of the sides are 2:3. Now if each side is 2 is to 3, then you can write 2y and 3y. And then from here, we say, well, ratio of AE to AC is 2 over 5. That's the turning point. So that is kind of a critical step here, where you have to remember and understand. This is a critical step. Now, you can split AC is a vector going from A to C, which is AD plus DC, right? AD plus DC is AC. And then you can write what DC is in terms of AB, because we want answer in terms of AB, and get your answer, right? I hope you appreciate how we use the property of scalar multiples and solve this question. Thank you and all the best.